So I should also warn, I'm somewhere where there's not great internet. So I'm wondering if somebody could just confirm that they can hear me okay.
Yes, all fine.
Thank you so much. Okay, so very quick background on who I am. I am a professor in the School of Medicine at the University of Colorado. I'm a genetic epidemiologist and biostatistician by training. And I primarily work in genetics of cardiovascular disease, diabetes, and obesity. So a little bit about the PRIMED consortium. So it was funded by NHGRI. It began in June of 2021, so last summer. So it's a new consortium. There are 7 individual study sites, and study sites don't necessarily mean just one institution. They were basically groups that put in proposals kind of focused on one area of methodology. So there are 7 of those. And then there's 1 coordinating center at the University of Washington. And PRIMED is not really focused on a specific phenotype. It's a little more focused on methods and diversity. So the overall goal is to improve methods and the application of PRSs in diverse populations. So at least, so in the US, most large funded consortium in the past have not really been focused on race ethnicity, but this one, what's specific about this one is specifically they were looking for non-whites, and again, the focus being on methods that address admixture and improving PRS for non-white and for diverse populations. So the 2 main goals are to improve the applicability of PRS in diverse populations, as I think pretty much everybody knows that currently PRS are largely, I'm not sure that I actually mentioned what PRS are, polygenic risk scores. So polygenic risk scores, for those that might not be familiar, are basically, it's a risk score that's based on individual genetic loci that are identified in genome-wide association studies. So these very large scale GWASs, basically you take all the individual variants that are associated. You try to pick a one representative for each independent locus, and you basically are adding them up into a risk score, and with the idea that these can be useful, potentially useful clinically. Since most GWAS are largely based on populations that are white, the goal of PRIMED is to really get better representation for PRSs. And then the other goal is to optimize the integration of large scale harmonization. So PRIMED investigators are located across 48 institutions in 9 countries. So it's a large consortium. PRIMED deliverables, the items that PRIMED is hoping to deliver is, again, harmonized data, both genotype data and phenotype wise. So PRS models, so that includes individual SNPs, weights, and covariates. These PRSs, these polygenic risk scores, can be done unweighted or weighted, where the weights would be the simplest kind of a thought of weights could be the betas, for example, from GWAS, but there could be other weights as well. Develop tools and resources from PRIMED investigators, develop policies and standards that better enable data sharing, including LC issues, and data and approaches that facilitate validation in clinical settings. So PRIMED, the goal of PRIMED is to work closely with the eMERGE consortium, which is focused on more on the clinical side of implementing genetics, where eMERGE is a consortium that eMERGE has been around for a while, and it's focused on bio repositories and electronic health record data. So here's a list, which is probably not very visible, but a list of the consortia and individual data sources that are used in PRIMED, that are proposed to be used in PRIMED. So it's really a very large mix. So I've worked on a number of large consortia, primarily US-based consortia that have tended to be more focused on cohort data. PRIMED is really going to be a mix of electronic health record data and cohort data, as well as case control data. So some of these things here are consortia in themselves listed here. So I am co-chair of the Phenotype Working Group in PRIMED, along with Dr. Laura Raffield from University of North Carolina. And the Phenotype Harmonization Working Group responsibilities include defining data format and documentation requirements for the providers of the data, as well as defining data standards for consortium data, for example, ontologies to be used. Also kind of leading the efforts for inventorying existing data, coordinate and prioritize harmonization efforts, establish and document best practices for phenotype harmonization, and define consortium phenotype data standards, as well as refining or updating basically standards in collaboration with phenotype specific working groups. So one thing that I should mention is that I think I showed you PRIMED just started last summer, so we're quite early in the process. I've worked quite a bit on some other large phenotype harmonization efforts and consortia. You know, it's really interesting seeing the talks here, how once you've kind of delved into and started working with phenotype harmonization, I think a lot of our minds start working the same way on the kinds of things that you need. But it also strikes me that here I am, I've been doing this for over 10 years, and you know, we're still, to some extent, there's still the need to kind of reinvent the wheel each time. Each situation, in my experience, is a little bit different. I think efforts such as what Dr. Burmeister mentioned earlier can really help reduce duplication of effort in the future. Another thing that I should mention, there are other working groups in PRIMED. Again, since things are getting started, we don't yet have the phenotype specific working groups. We're working on that. But there is also a genotype harmonization working group that's largely focused on imputation of data so that it can be combined. So current areas that the Phenotype Harmonization Working Group is focused on, we've thus far completed establishing an overall design for a pilot phenotype harmonization project and selected individual phenotypes for this pilot. So as I mentioned, there are no kind of specific, this consortium is not phenotype focused. And you know, there's obviously a very large number of phenotypes out there that could be focused on I think as anybody that's tried to do harmonization has done, you need to start smaller and move out and increase that. So we thought a pilot would make a lot of sense. So right now we're establishing what we're currently working on is establishing the guidelines for requesting pilot phenotype variables, as well as identifying additional phenotype areas beyond the pilot that we can start focusing on, as well as in identifying individuals and groups to lead the harmonization. So there is a coordinating center, but their funding is such that the phenotype harmonization will really need to be done by largely members of the consortium. Really kind of we definitely need champions as part of this effort. So the pilot phenotype harmonization project, the goals of what we're doing this for are to obtain data from a limited number of phenotypes. So picking a small number of phenotypes and from a subset of studies. So we're not even asking from data for all of the studies right now, and to try to do it in a very relatively quick manner. And we're going to use that that experience to gain a better understanding of the specific challenges in this setting. Again, a lot of consortia, at least US consortia, have largely, unless they've been pretty disease focused, have tended to be more cohort specific or more biobank specific. And this is really combining both of them. And also, we are using the Anvil system, which is the NHGRI cloud computing system in this consortium, and basically establishing a phenotype data set in Anvil that can start to be used by primed investigators, particularly ones that are focusing on methods and aren't specifically looking for a specific phenotype, just need larger data sets that are very diverse. So the variables that we're including in our pilot are some anthropometric measures, as well as some common covariates. So age at first record, a study baseline, self-reported sex, height, weight, BMI, and age at these measures. We're currently just looking for a single time point and not including longitudinal values. And then we selected a model quantitative trait, and after much discussion, we settled on LDL cholesterol, and we are going to use the emerged definition or a modified version of that for the biobanks, preferentially, knowing that it may not be available for every single biobank. And then cohorts usually have this pretty well defined. We are also going to be requesting, if available, use of a lipid lowering medication at the time of measurement. With the idea that, especially for the pilot, we're going to have a lot of flexibility in terms of what we are requesting. Again, this will only be single time point. We are also requesting as much documentation for whatever studies are going to be providing. So as much description that they can of the variables and the values in them. So a model case control phenotype, again, after much discussion and going through a number of phenotypes, we selected coronary heart disease, incident and prevalent. Again, there is an emerge consortium definition for this. And again, we will preferentially request that from biobanks. And again, for cohorts and case control studies, providing what's available, but providing definitions. So this first pilot's very much going to be focused on just kind of getting some data and getting the lay of the land and figuring out what's out there. Okay, so this is just, again, mentioning we will preferentially use emerge, and we will offer flexibility. One thing I should mention, LDL cholesterol, as with many quantitative traits, there tends to be a lot of differences, as I'm sure many people here know about, between, say, a cohort study and biobanks for electronic health record data. It's often not fasting, where for cohort data, it's almost always fasting, where they've requested people fast overnight. And the ability to collect medication data is going to be very different as well. In the US, especially in the US, where people really move in and out of the health system that collected the EHR information. I'm going to briefly mention Anvil, which is the cloud-based system that we're using. This is a repository and a computing environment being used by NHGRI now. So again, it's two things, and the big thing to know about it is that it's both a repository where data can be accessed, and it's a computing environment. So whereas I've often, in my experience, used dbGaP in the past, where you would download the data and then you do the computing locally, Anvil is going to have the data there, and then the computing will be done there. And if you're curious, here's the website for Anvil. Okay, so while we are doing the pilot, we are also trying to identify additional phenotypes for larger harmonization efforts. So we put out a phenotype interest inventory that basically lists a large number of disease and condition related phenotypes for investigators to indicate higher interest in. And then basically we're working on selecting a subgroup of those that kind of can get started, that will be used to form disease specific working groups that can get started on definitions and individual specific variables that will need to be harmonized. So currently what we're doing is once we've identified the phenotype areas, for example, cancer, where there is high interest, then we will be identifying individuals and groups to lead these harmonization efforts for that area. And then those groups will be charged with identifying individual phenotype variables, for example, specific variables for specific types of cancer. And then we will be requesting approximate sample sizes and definitions from each data source for each phenotype. Because you can imagine you could have a phenotype where there's very high interest, but there may be very small sample sizes, even across all of these different studies. And really what we want to do is make this information available to the wider group about both interest of individual investigators, as well as sample sizes and definitions of variables, so that individuals can make better informed decisions about where they want to pursue their effort in terms of work. So that's actually all I have. Again, big thank you to the rest of the PRIMED Phenotype Harmonization Working Group and NHLBI. And again, we're just getting started. And again, I'm really enjoying hearing these talks, and I thank you again.
Thanks so much, Lizzie, for giving us that great insight into the PRIMED work. I know a lot of it's still to come, but I think there's a lot of lessons that will be learned there because of the huge diversity, I think, of the cohorts and diseases that are being studied as well. I think it's going to be a huge challenge, but a hugely valuable resource when done. Are there any questions for Leslie? Melanie.
Hi, Leslie. Thanks. That was really, really great. I'm very interested in your cancer subgroup, so we should talk. I had a question. One thing I may not quite have understood. So you're saying you're collecting the data, and in some cases you're collecting expanded definitions for the data. So you gave the example of statins, for example. Are you saying that as a first step, you're just trying to capture everything in the definition, and once you have the collection of those definitions, you will try to harmonize them?
That's a great question. And yeah, so that probably requires a little bit of further describing. I think really, so there's kind of two things going on. So one is this pilot, where the pilot the variables that we have in the pilot may not be the final definitions. We're kind of going to give very loose definitions for this pilot. And again, one of the goals of the pilot is just to try to get data again all together into this Anvil computing requirement environment. But one of the things that we're doing with the pilot variables, but then kind of the next stage phenotype variables, is more focusing on what are all the definitions out there? What is possible? It's a little hard to say what we're going to harmonize to before we know all the definitions. So, we're at a really early step in terms of here where, you could come, I've certainly heard people come and say, well, you just need to use this definition. Well, that's great, unless, only 30% of your data sources can meet that definition. So again, it's kind of, and we're trying to do things also in parallel. So we're very much kind of starting in terms of our downstream phenotype harmonization goals, is very much trying to understand what are all the definitions possible that each one of these data sources have. And then that will help kind of direct where the phenotype goes. But we very much believe we're going to have multiple definitions for different phenotypes. For example, there could be like a self-report variable for something, and then there could be a much more specific physician diagnosed or healthcare provider diagnosed that maybe takes into, say, biomarkers as well. So yeah, so we very much see the future as being multiple definitions, but again, we're really at the stage of trying to collect a lot of information right now.
Thank you.
I hope
that makes lots of sense. No, that was a great answer. Thank you.